Have you ever stopped to wonder what really guarantees the medicine you take is safe and effective? Well, behind every single pill or injection, there's this hidden, incredibly rigorous process. And today, we're going to pull back the curtain on what happens when that process hits a serious snag. So let's just dive right in with the big question. What actually happens when a batch of medicine, we're talking something that could be worth millions of dollars, fails a critical quality test? This isn't just a minor hiccup. It's the start of what is basically a high-stakes, scientific detective story. You see, the official term for this kind of failure is out-of-specification, or OS for short. Now, you can think of an OS result as the ultimate red flag in drug manufacturing. It means a sample just didn't meet the super precise standards it was supposed to. And when that flag goes up, you better believe an immediate, all-hands-on-deck investigation gets launched. All right, so that alarm bell has just gone off in the quality control lab. What happens next? Well, a specialized team of investigators is pulled together right away to figure out exactly what went wrong. Think of these folks as the main characters in our detective story. It all starts with the QC analyst. They're the one who actually ran the test and first saw the failure. They report it to their QC manager, who kicks off an investigation right there in the lab. Now, if they can't find the problem in the lab, the case gets escalated to the production and engineering managers, and the person overseeing the entire thing? That's the quality assurance manager. They're the one who makes the final, critical call on the whole batch. Now, you might think they'd tear the whole factory apart, but that's not how it works. The investigation starts small and super focused. This first stage, known as Phase 1, happens entirely within the four walls of the laboratory. The goal here is pretty simple: rule out any mistakes that might have happened during the test itself. So, this Phase 1 is broken down into two logical steps. First, the manager and analyst do a quick, preliminary check for any obvious, oops, kind of mistakes. If nothing immediately jumps out at them, they have to move on to a much deeper, more formal investigation, where they review every single tiny detail of that original analysis. So, what do these obvious errors look like in real life? We're talking about things like a simple math mistake in a calculation. Maybe the power flickered for a second and messed up an instrument. Or it could be an equipment failure, or even something as human as accidentally spilling a little bit of the sample. If they find a clear, documented error like this, the original result can be thrown out and the test is carefully run again. Okay, but here's where it gets really interesting. What happens if they check everything? The math, the machines, the analyst's notes, and find absolutely nothing? Nothing wrong at all? Well, this is the point where the investigation escalates, and it escalates big time. And just like that, the plot thickens. With no lab error to blame, the investigators have to consider a much more serious possibility: that the problem isn't with the test, but with the medicine itself. The whole investigation is about to expand way beyond the lab and onto the entire factory floor. This is it. This is the official trigger for what's called a Phase 2 investigation. It's basically a formal declaration that says, okay, we couldn't find the cause in the lab, so the entire manufacturing process is now under the microscope. And when I say under the microscope, I mean it. They go deep. They'll review the batch manufacturing records. That's basically the step-by-step recipe for that specific batch. They'll comb through equipment logbooks, check environmental controls like temperature and humidity, and even verify the quality of the raw materials that went into it. They'll also look at data from previous batches to see if this is a one-off problem or part of a bigger trend. And through this whole thing, there's one guiding principle they all live by. It's a quote taken right from the official procedures, and it's their golden rule. Every step has to be thorough, timely, unbiased, well-documented, and based on solid science. There's just no room for guesswork when patient safety is at stake. So, after gathering all this evidence from both the lab and the factory, the team gets to this critical crossroads. They have to decide what to do next, and, trust me, their choices are very, very strictly controlled. Okay, so we need to get two terms straight here, because they sound similar but are worlds apart: retesting and resampling. Retesting means you go back and test the original sample material again, the same stuff that failed the first time. Resampling, on the other hand, means you go out and collect a brand new sample from the batch, and they are absolutely not interchangeable. And I cannot stress this enough. Resampling is incredibly rare. You can't just keep taking new samples until you finally get one that passes. That's a huge no-no called testing into compliance, and it is strictly forbidden. A new sample can only be taken if there's solid scientific proof that the first one was somehow messed up or didn't represent the batch as a whole. And all of this leads to the final verdict. If the investigation confirms that the OOS result was real, the most likely outcome by far is that the entire batch gets rejected, thrown out. In some situations, the investigation might get even bigger if there's a chance other batches are affected. And releasing the batch? That is extraordinarily rare and only happens if a mountain of scientific evidence proves it's safe despite the initial failure. Phew. Okay, we've just walked through this incredibly detailed, almost forensic process. But let's take a step back for a second and just ask the most important question. Why? Why does all of this matter so much? Because when you strip it all away, every step, every checklist, every signature, this entire scientific detective story has one single crystal clear purpose: to protect the patient. That's it. It's all about making sure a faulty product never, ever makes it out the door. And there's a real ticking clock here. The standard procedure actually gives them a target of 30 working days to get these complex investigations closed. That just shows you how urgently they need to get to the bottom of any potential safety issues. So the next time you open a bottle of medicine, just remember this invisible system. It's this complex, science-driven process of checks and balances, working tirelessly behind the scenes to make sure the medicine we all rely on is safe and effective. Every single time. It really is a fascinating peek behind the curtain. I mean, this whole process protects your medicine, but it gets you thinking, doesn't it? What other invisible systems like this are out there quietly working every day to ensure the quality and safety of all the other products we use?